Good morning, and thank you for joining us for the presentation Outback SkyBox Introduction, brought to you by AEE Solar. Before we begin, if you're experiencing any technical difficulties, please notify me by typing your question in the question pane of your control panel on the right side of your screen and click send. We will have a question and answer session following the presentation. You are welcome to submit your questions at any point during the webinar, and we will do our best to answer as many questions as possible after the presentation has ended. There will be a brief survey that will pop up in a new window immediately following the webinar. Please, if you could take a couple of moments to complete it, I will go ahead and email you a copy of the presentation. If there are no questions, I'd like to go ahead and introduce our presenter today, Bo McLuhan, Senior Product Manager with Outback Power. Bo, I'm going to go ahead and pass the presentation over to you.
Great. Thank you, Caitlin. Thanks to everybody on the line today. I really appreciate the opportunity to speak with you about SkyBox. So our agenda this morning is to talk first about a little overview in terms of the residential solar and storage market, and then we'll do a SkyBox introduction, talk about some of the SkyBox applications. We'll talk about some of the battery options with SkyBox, and then we'll step you through the getting started with your SkyBox installation. So first, a little bit about who Outback Power is. We're a brand built around batteries, built around storage and backup. And we've been in business since 2001 with a history of innovations that have really led up to this moment of producing this new to the market product like SkyBox. The market for residential solar and storage is growing tremendously. This data is from GTM, Green Tech Media, and we're seeing that residential energy storage demand is expected to triple in the next year. So the market is, to quote Wayne Gretzky, the puck is, or to paraphrase Wayne Gretzky, the puck is going in the direction that we are already skating, and we're going to be there with our hockey stick. So it's an exciting time to be doing storage for residential solar. With respect to applications, it's about reducing energy costs no matter what the utility company throws at the ratepayer. So it's time of use energy optimization. SkyBox will serve loads from PV first, and then after PV, it'll use the cheapest power available, be that from grid or from battery. We support non-export or self-consumption. So that's serving loads from PV first, and then automatically adjusting your PV harvest to match the loads. And then where there is zero export allowed back into the grid, we ensure that no power flows back. We also support net metering with or without backup. So in that case, all excess PV generation is sent back to the utility company. And then the final application is this maximum independence idea, right? This is for people who want to, for one reason or another, attempt to be as independent from their utility company as possible. So we open our grid relay and then power loads from only PV and battery as much as possible. Okay, this slide is showing the current state of existing residential solar. And what this is saying is there's a tremendous amount of installed capacity out there today that doesn't have necessarily batteries added to it. And there's an opportunity to go back to those existing installs and add a product like SkyBox with battery backup to all of those sites. So what are some of the changes in the storage market today, right? The traditional uses for energy storage were off-grid, right? Where a customer was too far away from the utility company, they wanted to bring electric power out into rural areas, and grid-tied battery backup. So there were situations where you had an unreliable grid, where you wanted to do storm hardening, or where you wanted to have some sort of medical or uninterruptible power supply type load being served. And some of the new uses that are driving new energy storage today are the utility companies are changing their net metering policies. They're increasing prices, and that's making storage more competitive and more interesting to customers. And then customers want to have PV production, storage on site be independent as much as possible. There's also tremendous interest, especially in commercial, but also with residential, to provide extra peak shaving capacity for high use times. And then there's tremendous need for backup power. You know, we see from this Eaton's blackout tracker that the number of people, and this is just counting number of people impacted by outages, not the duration of the outages, but the number of people impacted by outages is increasing year over year. And so that's driving a tremendous interest, tremendous need to have a grid-friendly battery backup solution. Okay, now we'll transition directly into SkyBox applications and introduction. The artwork on the right are actual screenshots from SkyBox. I put 2 screenshots on there by way of talking points about SkyBox. In the first upper screenshot, we see the loads being served by SkyBox and 100% self-consumption in this particular case. And in the lower part of the window, we see the picture of SkyBox's home screen showing that it's been set up for non-export. So it's got zero power is being sent back to the grid. And then we'll talk more about this in detail a little bit later, but that PV production is simultaneously powering those loads, charging the batteries, and we're supporting backup power. We've got a genset that is connected to the SkyBox and is ready to go in case of grid outage. So we're doing that self-consumption and we're supporting backup power. Okay, SkyBox is a true hybrid energy management system. It's 5 kW in any direction, and it's 120 volt, 240 volt, so split phase 60 hertz. So that's residential North America market. It's resilient, and for us, it's resilient, adaptable, simple, and intelligent. And Caitlin, I'm having trouble with my screen here, so there we go. So for us, that means that resilient gives you immediate backup power. It supports a generator. It's a durable product that results in fewer service calls for you, and we provide remote support. So you can log in remotely from anywhere and check on your customer's SkyBox unit, and you can have remote firmware updates available for them. So if the utility company changes the interconnection agreement or it changes how the SkyBox needs to send volt var, for example, we can support that via new firmware updates, and those are pushed from server out to the homeowner, so you don't have to roll trucks to go upgrade firmware out in the field. So SkyBox is adaptable. It's NEMA 3R, so it's a drop-in replacement for existing grid-dependent string inverters, and it works with the widest variety of 48-volt battery chemistries, and we'll talk more about that later too. But it supports lithium-ion as well as the lead-acid batteries. And then SkyBox is stackable, and that's just enabled via software. We think that it's pretty simple. We think that it's making your life easier. So tell me about that. We want to hear your reactions to that. If that's not the case, there are things we can do to improve that even more. But we think it's pretty easy, pretty fast to install. It seems like it's pretty clean BOSS. It's balance of systems, or the load center underneath SkyBox. And it's all in one. No additional hardware needs to be hung, and it's pretty simple, straightforward. And it's a high PV voltage input, so that allows long strings, and you can just move your existing strings over if you're doing a retrofit. And then finally on this slide, there's a tremendous amount of intelligence built into SkyBox. So it's dynamic power management, and I kind of touched on this earlier, but it's the ability to support any new regulatory needs that come up just via software, via firmware update. Physically, SkyBox is a 5-port design, and those ports are all controllable at each connection point. The grid, load, and battery are bidirectional. That allows us for adjustable export or import at any of those locations. So today, what I'm showing on this slide is load only going in one direction, but we can support AC coupling on that load port and have power going in the other direction as well. So our core values are all built around enabling you to take charge of your energy, your solar. And SkyBox is designed with that in mind. It's designed to be a simple, smart, cost-effective, renewable energy system for a mainstream grid-tied, eventually worldwide market. And again, today we're starting with North America. So again, it's resilient, adaptable, simple, and intelligent. It is residential energy storage system for backup power and self-consumption. It can be installed with or without energy storage. And it's comparable in terms of ease of use, ease of installation, ease of operation, and efficiency and reliability to your grid-dependent string inverters. So we also have the ability to measure and control power from multiple connection points. And again, energy storage optional, not something that you have to have up front. If you don't want it, you can always add it later. On this next slide, the graphs deliberately don't match the text text beneath. I wanted to put some additional screenshots of SkyBox and spend some time talking about them because they really echo the market drivers for storage. And what we see in these graphs, what you see in these screenshots from SkyBox, is we see PV production, as you'd expect, peaking in the middle of the day. And on the right, you see that the loads reach their peak late in the afternoon after the sun started to go down. That's peaking around 8, 9 p.m. at night. So what's SkyBox doing in this particular case? Well, it is serving those loads early in the morning and charging batteries simultaneously. And then in the afternoon, it's discharging the battery and using that to supplement the PV production to serve those loads and have 100% self-consumption. So there are the financially driven use cases for solar plus storage. And SkyBox is the easiest storage solution to install. It supports PV self-consumption and it supports time of use energy arbitrage. And then there are the financially driven use cases, backup or resiliency, and it's a future-proofed PV system. So we have the ability to add additional, you can add a generator later, for example, and we can adjust software firmware later on to support different regulatory requirements when they come down the road. And then, not to discount these at all, there are also the emotionally driven use cases for why someone would add solar plus storage. So those are the situations where the customer wants to have backup power, not for a financially driven motivation, but because they simply don't want to leave their home. They don't want to leave their pets or get a hotel or that sort of thing. Replace the food in their refrigerator. And then the other emotionally driven use cases are for the customers, again, and not to discount this justification, but they're the customers who've had issues with their utility company and want to reduce their dependence on them. So SkyBox supports them as well. SkyBox is all about automating your savings. We make it easy for you, the installer, and for the homeowner. For you, the installer, you just enter the data and SkyBox maximizes the ROI. So we determine the lowest cost energy source and we use that. If the battery is less cost than the super off peak rate, then the battery will charge in PV only. And we can set any battery reserve level for backup power from 0 to 100% SOC. So some of the potential inputs that you would have for SkyBox are your time of use rate schedule, whether or not you're allowed to export energy. You know, in cases like Hawaii, for example, where it's a non-export situation, you enter in that you can't send any power back, and SkyBox will handle it from there. And then the other input that you would enter in is what your replacement cost is to put the battery in at its end of its natural life. And then finally, how much of the battery you want to leave in reserve for backup power. Here's an example, payback with time of use. So with this financial model, we put in a new PV installation in Sacramento Municipal Utility District. With battery, it pays for itself in 6 to 8 years, and that's up to 2 years faster than the comparable PV installation without batteries. So tremendous energy savings per year. And again, we assumed a pretty big array and a pretty big initial investment. We assumed some rebates and incentives, and we saw the customer's monthly utility bill go from $330 a month down to $50 a month. SkyBox specifications. So again, it's 5 kW in any direction. It supports backup power with energy storage, or you can add energy storage as an option. 120 volt, 200 volt AC, and then up to 60 amp AC pass-through from the grid. So if you have high surge loads, that's where you'd get your additional surge capacity. The MPPT voltage window is very, very wide. It's down as low as 250 volts and up all the way up to 600 volts. So again, if you have existing strings of PV, you can just move those over to SkyBox directly. Battery voltage window down to 42 volts up to 60, so it's your traditional 48 volt battery. Wide operating range, excellent total harmonic distortion. Again, I touched on this earlier, it's field upgradable firmware, and that's upgradable over the internet as well. We have non-volatile memory built into each SkyBox unit, and then it's NEMA 3R, so you can install it outdoors, out on the side of the garage, or inside, wherever you like to do it. So the value proposition for SkyBox, again, it's those financially driven use cases, the functionally driven ones, and the emotionally driven ones. And we think that we've got the feature set to support those primary value drivers, right? So it's a true multi-mode inverter. It can be installed with or without batteries and add them later. It's immediate backup power. So no downtime, no need to reset digital clocks, no need to reset your router. You're not going to have your lights flicker or need anything else to be reset when the grid goes out. It's full 5 kW in any operating mode, and it is off-grid capable. So to us, that means that it's generator friendly and that it's grid forming. And then finally, the final feature that we're going to talk about on this slide is that SkyBox is compatible with all of those low-cost batteries. So you can use their existing vented flooded lead acid 48 volt or a variety of lithium-ion battery chemistries. We offer advanced training, so that allows customers to get a hands-on experience with SkyBox. You know, we've been doing this certificate training program here at Outback that applies for your NABCEP credits for a while now, and we're continuing to build on that expertise and share that with the industry. So we've got a one-day SkyBox specific add-on to that class that is going to be available later this quarter, and that's going to allow students to learn how to sell, design, install, and program the SkyBox system that's optimized for grid-tied energy management. If there's additional interest in that, feel free to reach out to me and Caitlin, and we'll get you in the queue to get signed up for that class. Okay, with respect to battery options for SkyBox, this is a picture from one of our installs in California. This is showing a SkyBox with Simplify lithium-ion batteries attached to it. So SkyBox batteries support low-cost lead acid, or a variety of advanced lithium-ion chemistries. And then the best battery might not be the same for every application. So you can support, for example, a daily cycling lithium-ion battery. This is a photo of the LG Resu. You can support a partial state of charge for self-consumption. That's the Outback Power PLC battery. Or for exclusively for backup power, you could have a battery that was used mostly for float, and that's as an example of that, that's something like an Outback PL battery. So let's talk about getting started with SkyBox. This is a photo from another installation. And they've connected, in this case, battery over here in the middle of the picture, PV over on the right, and grid and load panel. And we'll talk more about this in a little bit of detail. Those CTs that they have in there are just for the purpose of, they were doing some initial early beta testing with us, so those are completely optional to install there. You would typically install your CTs out at the main so that you can move your point of measurement from SkyBox's grid port out to there. SkyBox with the load center is about 47 inches tall. It's about 9 inches deep. Hangs on the wall, pretty simple and straightforward. I'm not allowed by OSHA to tell you that I've hung it by myself. It's a 90-pound total. It's the 90-pound maximum lift of the inverter, so it's a two-man lift. But one of the things that we do is we put this knockout over here in the back upper top of SkyBox. See if I can bring up a laser pointer. That work? Yeah, it looks like it's working. And then that supports 3/4 inch conduit. So you'd slide a little stub of, something that's 3 feet, 5 feet long of 3/4 inch conduit through there. And then that provides a good lifting point, a good handle for two people to put SkyBox up on the wall. Turn off the spotlight. Okay, we've put together a quick start guide. It's a simple 4-page quick start. It steps through where to hang the mounting bracket up on the wall, and it spends a lot of time showing you the wiring diagram in case you need that too. So all of that documentation is done and ready to go. And then we've put together an applications note on string sizing should you need it. You typically do something like 9 to 13 panels in 1 or 2 strings, and SkyBox has a single MPPT. Here are a few pictures of the balance of systems, or the BOSS, the load center that goes under SkyBox. And from left to right, that's a battery connection, grid connection, generator, load, channel for PV, channel for communications, or your low voltage lines. And then you'd land the PV over in here. We add a plastic dead front for safety. And this lower right-hand picture is showing that attached. That you typically do that after you added in the wires. So we think that's pretty simple and clean and straightforward. In order to make, in order to do the commissioning for SkyBox, the only connections you have to make are battery or grid. After that, you're done. You can turn SkyBox on and you can go from there. Anything else is optional. So PV optional. And if you have grid instead of battery, then battery is optional. SkyBox has a resistive touchscreen. It's rugged, so it's built for outdoor installations. It's simple one-finger navigation. And then as an option for you, the installer, you can connect to the local network, or you can make a quick local network and then view or modify any of the configuration parameters from any tablet or PC that's on that network. And then if your customer or your router allows access to port 3000, then this can be done over the internet too. We use a simple 5-tile overview for easy navigation, and then above each one of the tiles, the direction of the arrow shows energy flow. So up is going to SkyBox, and then down is coming from SkyBox to that particular port. And then within each tile, the color is used to convey information. So for example, in the solar tile, gray would mean sleeping, yellow would mean that it's either doing an MPPT sweep to maximize power, or it's checking for any number of faults from arc fault that's built in internal to SkyBox, that check ability. Ground fault also built in within SkyBox, or an impedance check, also something that SkyBox can do without any additional hardware. Okay, in this particular example, SkyBox has been programmed for non-export. PV is serving loads and batteries simultaneously. The generator is on, and that's exercised. So it's a scheduled thing just to make sure that the generator is working. And so in that case, the grid relay inside SkyBox is open because it's exercising and because there's grid power available. Displaying those graphs, these are some things that the homeowner can do. Those are easy to do, and it's easy to click on any one of those tiles and bring up the graphs for that particular tile. So in this example, I've clicked on solar, and instead of showing just the daily harvest, I'm showing weekly, and then switching over to month, and then switching over to yearly production. And then it's easy to choose what sort of data is displayed. So the default would be to show peak kW production as well as total energy production, and you can easily toggle that off, turn that off, and just look at your totals. SkyBox supports the industry-leading solar plus storage website. So that's OpticsRE. It allows you to take charge of your solar from anywhere, and pretty slick, easy to use interface. So in summary, SkyBox allows you to take charge of your energy. It has PV and battery backup delivered seamlessly from one all-in-one solution. It complies with all grid interconnection limitations. Supports time of use, so that allows you to use your PV and your battery when electricity is expensive. SkyBox is DC coupled, so that is direct DC link from PV down into the battery. That's the highest most efficient way to do it. And we support remote monitoring and firmware updates via OpticsRE. And finally, SkyBox is compatible with the widest range of battery chemistries, from something like an LG Chem Resu 1048 volt to all of your existing Outback Power lead acid batteries as well. So with that, I'd like to say thank you for your time, and I'll turn it back over to Caitlin, and we'll start doing our best to answer questions. And if I can't answer a question, we'll tag that for later, and we'll come back to it. We'll get you the answer soon.
Perfect. Thank you, Bo. So I'd like to go ahead and start off our question and answer session now. If you have a question, please go ahead and submit it through the question pane located on your control panel. Again, we'll do our best to try to answer as many questions as possible. You can exit the webinar at any time during or following the question and answer session. The survey will pop up in a new window once the webinar ends. Go ahead and give us your feedback on the survey, and I will send you a copy of the